Hello all, welcome back to Data Science Brain. In this video, I am going to show you a fun project where we will be detecting multiple colors in an image or a video using OpenCV and Python. As you can see, this is a Rubik's Cube and we are able to detect blue and green and yellow colors from this Rubik's Cube. So let's get started. First let us import all the necessary libraries. So we will import numpy as nb and import cv2. So if you haven't already installed OpenCV, so OpenCV is the library that we'll be using for this color detection and all the image manipulation and everything. So you have to install. If you haven't installed, you can install using pip. So pip install. I think it's OpenCV Python something. You can search it on internet and you have to install it. Okay. So I'll be using PyCharm IDE for this project. You can run the same codes in Jupyter notebook as well. Okay. So if anyone is using Colab, then you have to find a little different way to show the video capture using OpenCV. Okay. So I would suggest you to use any IDEs or Jupyter notebook, anything that is running in your system. Okay. So we have imported cv2 and numpy. So we'll be using numpy. So in OpenCV, the images are stored in as arrays that are numpy arrays. Okay, so that's why we need numpy for some array manipulation. So we have imported the necessary libraries, and so let us like write the main function, and we will do the outline of our project. So first of all, what we need? So we need a video, right? So we need a video to detect the colors. So we will first capture the video. So we will say video capture function from OpenCV to capture the video. So we will pass in 0 here. So this 0 represents the camera number. Okay. So if you have multiple cameras, you can adjust the camera number according to your preference. So I only have one camera, so I will give 0 here. Okay. Um, so we will take in the capture and we will write a loop here while true. So why do we write while true? Because we need to run this loop. I mean, we need to get the input till we say no, right? So we need to keep getting the frame. So this will read frame by frame. Okay. So we need to keep getting the frames till we say it to stop, right? So till true, I mean while true, we will take in return and frame is equal to cap dot read. So read is a OpenCV function which we use to read in the frames. Okay, so this cap dot read will return two true values. I mean two values, return and frame. So this return will be a boolean value, just representing whether we are successful in reading the input. So and the frame will be containing the actual frame of the video. Okay, so we will say if ret. So if we have returned this video, if we got the video, now we will do some let's say initial like what to say, we'll say getting the video ready for detection. Okay, so that's what we are going to do here. We'll do some little bit of minor adjustments to the video. So first thing will be we will mirror the frame. Okay, so why do we need to mirror the frame? So the video that will be captured and shown us to us will not be in mirror form. Okay, so it will not be like looking at a mirror. So if I basically if I raise my left hand, so the left hand will be on the actual left side of the screen, which will be visible to us in the right side. So I hope you get what I am saying, right? In a mirror, what will happen? If I raise the left hand, it will be raised on the left side, of on my left side, right? But it is not actual left side of the mirror, isn't it? It's the right side of the mirror. So we need that kind of visual to actually understand what's happening. So that's why I need to flip this frame to make it look exactly like we are looking in a mirror. Okay. So I will write cv2 dot flip. This is the flip function we will use to flip the frame, and 1 means horizontal flip. If you write 0 here, it will flip vertically. Okay, so I need to horizontally flip this frame in order to make it look exactly like I am looking at a mirror, and then I will also brighten the frame. Okay, so why do we need to brighten the frame? So this is not necessary for some of you guys, because this is only necessary if you have a really low lighting conditions, and also if your camera is of not good quality. Okay, so in these two cases you might have to make your video a little bit more brightened. Okay, so that's why I'm writing this function where I pass in our frame, and I will write in a factor here. So by how much I need to brighten the image. So image means, I mean, that the video is captured as image by image, right? Frame by frame. Okay. So we'll pass in one of those frame and the intensity to which we need to improve the brightness to this function that we have in written already anyway. So we'll write this def adjust brightness, and it will take in the frame and what the factor, isn't it? So default, let us set it as 1.2. Okay. So what we do need to do, so now see, there's one more thing. So images are stored in RGB or BGR format in OpenCV. Okay, so it is stored in as BGR format. You might have heard about RGB format, right? So any pixel in an image can be represented using three colors: red, green, and blue. Okay, so this red, green, and blue colors can, I mean, the combination of these three colors can make any pixel in an image. Okay, any color. Okay, so that's how images are stored in OpenCV. Okay, it's in BGR. Okay, not RGB. It's in BGR format. So the first will be blue, the second will be green, and the third will be red. So there will be three channels. There will be three channels. For example, imagine there is an image with dimension 100 by 100. Okay, like 100 height and 100 width. So in OpenCV, this image will be stored in as 100 by 100, and then there will be three channels of this 100 by 100. Okay, and each channel will be having a value ranging between 0 and 255. So 0 represents absolute black, and 255 represents absolute white. Okay, and other colors are in between that. So so that's how images are stored in OpenCV. Okay, so in that way, if we are getting the image BGR, we cannot increase the brightness, right? So for increasing the brightness, we need to convert our frame into another way of representing image, that is HSV, or hue, saturation, and value. Now hue, saturation, and value, hue means like the shade of different colors. Saturation means the intensity of that particular color, and value means the brightness, right? So that's what we need, isn't it? We need brightness, so we need V. So we need to take in V. So for that, first we will convert this frame which is in BGR format to HSV format. So we will say CV2 to color. We have this function BGR to HSV. So this will convert the image from BGR format to HSV format, and then we will split its H, S, and V components. Okay, so only then we can take in the V component, which is the brightness component. So we will call another function CV2 to split, CV2 dot split, and we will pass in our HSV image. This will split it into its components, that are hue, saturation, and value, and we will take in the value component, and we will use another numpy array. As I have mentioned, anything is stored in as numpy arrays in OpenCV, isn't it? So we will use a numpy function to manipulate that array. So we will take in our V, and as I have mentioned, we are increasing it by a factor of 1.2. So we will multiply it by 1.2. Now we will do the A min and the A max. So what are these? So these are the min and maximum values. Okay, these are the clipping values. So if V into factor goes below 0, it will clip it at 0. It will make it 0. If V into factor goes beyond 255, it will clip it at 255. It will make it 255. Okay, it will round off to 255. So why do we need this? Because all three channels, and also in HSV format, the H ranges from 0 to 180. Okay, and the S value, saturation value, ranges between 0 and 255. Okay, and value ranges between 0 and 255. So all these two values ranges between 0 and 255. So that's the reason why we need to clip it between 0 and 255. Okay, so only then we can save it back, isn't it? So it's for making it suitable according to the format. Then also we need to make it unsigned integer. Okay, so we are making it unsigned 8-bit integer. So again, images, these array images are stored in as unsigned 8-bit integers in OpenCV. Okay, so that's the reason why. So basically these things are just formatting. Okay, we're just formatting it to the right format. So basically we are increasing the brightness, that is V value, by factor. Now we will combine this again, and make it into, and the original, we will merge everything. We will merge this H, S, and V values back together. Okay, so H, S, V. So V will be the updated V. Okay, so we have increased the brightness. Now we will return it back to its original form. Okay, so we will say CVT color, No. CVT color, and we will pass in our HSV image, and we need to convert it to what HSV to color, HSV to BGR. Okay, so we have converted it and we have returned it. So this brightened frame has the new brightened image. Okay, or frame, the frame, brightened frame. Okay, now comes our actual let's say detection part. Okay, detection part. Okay, so in this we will first mention the colors that we need to detect. Okay, so let's say colors to detect. We will make an array of colors that we want to detect. We need to detect blue. I need to detect green. Then I need to detect yellow. Let's detect these three colors. Okay, these are easier colors to detect. So let's just try with this. Okay, so colors to detect, and then we will write a function to detect these colors. Okay, so we need a variable to store that detected colors. So we will store it in detected colors, and we will get that detected colors from this function that we haven't written it. So detect color is the function that we are going to write, and we will pass in the colors that we want to detect, and also then what we need to detect these colors from where brightened frame. Okay, so we will pass in the brightened frame and the colors to detect. Now let us write this, the most important function in this tutorial, this project, detect color function. Okay, so it will take in frame and what colors, isn't it? So again, once again, we need to convert this into an HSV image. We will say, we will call the same function cv2 dot, let us copy it, cv2 dot, okay. So it has converted it in HSV image. And now what? So there will be multiple colors, right? So there are basically three colors that we need to detect. So we'll say we will keep an array that will that we, to which we will append the detected colors. Okay, the properties of the detected colors. Okay, and now we will loop through the colors that we want to detect. So let us say color name in colors, for all the color names in colors. So we need a range, right? I mean, in our image, we can just say, I need blue. So what blue? Like what is blue? So there are different kinds of blue, isn't it? So this is a blue, isn't it? This is a blue. This is a blue color. Like there are other blue colors here. Like I mean, this is a blue. So there are different shades of blue, isn't it? So we need a limit, like we need an upper limit and lower limit that represents the range of blue color, isn't it? So for that, what do we need? We need upper limit and lower limit. So let us say lower limit. So only then we can detect it, isn't it? We need a range of values that we are trying to detect for the blue color, right? So let's say upper limit and lower limit. Sorry, upper limit is equal to, we will again write another function to get the limits for this particular color. Okay, we will pass in the color name here, and we will get the range of those color in return. Okay, we will write another function, get limits, which will take in the color, and we will write a dictionary, like HSV values for colors. Okay, so these are all HSV values. Okay, as I have mentioned, in OpenCV, HSV values are stored with H value having range between 0 and 180, the other two having range between 0 and 255. Okay, so for blue, just write in whatever I am writing here. Okay, so I have this already written. I mean, I have given my link to the code, GitHub code in the description. You can check it. You can just copy and paste it. Okay, you don't have to type it in. So you can get this from internet. Okay, just copy and paste this. So blue have this range, yellow have this range, and green have this range. Okay, so these are the upper and lower limit, but we cannot just send it just like this. So we will say, let's say color that we have taken from here. So we need to check which color this is and return the particular upper and lower limit, right? So first we need to convert this into lowercase. Okay, because if in case in the future, we are making this into an application and the user enters the color name in capital letter, we need to convert it into small letter before checking. Okay, so we will now, if color is in colors. Okay, we will return its upper and lower limit. Okay, so we'll get the upper and lower limit. Okay, you can just copy and paste this from here. So where is that? Lower limit and upper limit is equal to colors of color, isn't it? Okay, we will get in that. Now we cannot just send it back like this. As I have mentioned, it is stored in us 8-bit unsigned integers, right? So we need to convert this into these two into 8-bit unsigned integers. So we'll say nb.array lower limit and d type is equal to nb dot unit. I mean unsigned integers, 8-bit unsigned integer arrays. Okay, so these are 8-bit and unsigned integer number arrays. Okay, so that's how this is stored in OpenCV. That's how we need to return it. Okay. Okay, so we will do the same for the upper limit. Okay, and see if any of you know better about these things, do comment it down there. Okay, I haven't done much research on why we need to convert these values into this. So if anyone knows, kindly comment it down. Okay, and or if you need any video about more explanations on this, then kindly drop that in comment. I will definitely do a research and I will let you know. Okay, and if we don't get the color, I mean this particular color in this dictionary, if you don't have this in dictionary, we will simply return none. Okay, saying that we don't have it. Okay, so we have these colors returned, I mean the lower limit and upper limit of these colors returned. Now with this, so we will check. Okay, if lower limit is not none and same thing, but with upper limit is not none, if these both values are not none, now we will create a mask. Okay, so what is a mask? So a mask will basically, so imagine like this is the video feed. Okay, I don't think if you can see this, or maybe let's say, so this whole part is the video feed. Okay, and I want to dictate this blue color. So what this mask does is that it will make this part of the video completely white and everything else completely black. Okay, in that way we have masked this region, isn't it? We have detected this region, we haven't recognized it, but we have detected this region, isn't it? So and that's what mask does. So we will say in range. So what do we need to mask? We need to mask a particular part of what? A particular part of what? Particular part of this HSV image. And what do we need to I mean which part we need to mask? We need to mask a part that is between these two ranges. Okay, so it will mask, it will basically convert every pixel in this range into white, absolute white, and every other pixel into absolute black. Okay, so this mask will not be I mean we'll be having some noises and it will not be perfect. Okay, so in order to make this perfect, we will write, I mean we will pass it through another function called threshold. Okay, we'll say threshold and we will pass in our mask. I will explain it. Let us first write it. We'll say threshold value and we will say max value, and we will say we need binary thresholding, isn't it? Because we only need two values, black or white, and we will use cv2 dot cv2 dot thresh otsu. Okay, otsu's method. So we are using otsu's method to find the perfect threshold for converting the pixels in our image into black or white. So the otsu's method will look through the histogram of this image and it will find the perfect threshold. So anything below that threshold will be made to absolute white, and anything above that threshold will be made to absolute black. Okay, so that's how this is done. Okay, and yeah, and so this will actually smoothen out any noises, any, I mean some of the noises in the image. Okay, and this will also not smoothen out noises, this will actually uh, like enable us to predict the perfect mask. Okay, predict the regions that are actually, let's say if the color is blue that we are trying to detect, then it will it will enable us to detect that blue color better or mask that blue color better. Okay, using this threshold. Okay, and now we are going to like reduce the noise in our detected mask part. Okay, like in our masked part, like there will be some black dots inside this white mask. Okay, so there is a possibility that some of the pixels are not turned to white, so it will affect our detection. So in order to reduce that, we need to do some noise reduction. So for that, we are first creating a kernel. So I will tell you why do we need a kernel. So again, this is, as we have mentioned again and again, this all should be unsigned 8-bit integers. So this is a much larger kernel. Okay, so kernel is basically a number array having all ones. Okay, this everything inside this number array will be 1 1 1 1 1. So this is a pretty big kernel. So what this does is that this kernel we will okay, in simple terms, as I have mentioned, image is simply a number array, right? So this kernel will go on top of this number array. Okay, so we will basically slide this kernel on top of our number array, and whichever part this kernel touches, it will turn that into absolute, I mean, it will reduce all the noise inside that part. Okay, so it will I mean, make the black parts white, and it will make actual black parts into white, I mean, actual black parts into black. Okay, so it will reduce the noise, of the foreground. Okay, so whichever part this kernel goes through, it will reduce the noise there. Okay, so that's in simple terms. Okay, we can further explore this. I will actually, for my subscribers, I will actually give the link to the theory of all these things. Okay, so okay, we can, I mean, basically search this on internet and find it out. Okay, I will not go into details of these things because it will be out of the scope of this video. So so we'll take in that our kernel, and we will put it through our mask. Okay, so we will say we need to do what kind of morphology we need to do. There are different kind of morphology. Okay, morphology, morph, open, close, rectify, all these things. Okay, so what do we need to do is morphological closing. Okay, so you can watch some YouTube videos on what morphological closing is. So basically, in simple terms, it will reduce the noise. Okay, so morphological closing in I mean, in computer vision is mostly used for reducing the noise of the foreground. So what is a foreground? Foreground is the actual place that we have detected the color. Okay, so it will reduce the noise in that foreground, morphological closing. Okay, and for that morphological closing, we are using this kernel of 9 by 9 size. Okay, so whichever place this kernel goes through, it will reduce the noise in that place. So morphological closing is a standard process which has two process called dilation and like like erosion and dilation. You can learn more about it. So basically, erosion will remove the pixels, and dilation will add the pixels. Okay, so so what happens after dilation and erosion is that we will get an foreground which does not have any unwanted noise. Okay, so this is used for noise reduction. So finally, we have received our mask after making it little bit perfect and removing all the noise and everything. We have received our mask. Okay, so now what do we do? So now we need to find the contours. Okay, so why do we need contours? Contours are used for drawing the bounding boxes. Okay, so I mean, we need to get the contour. What is a contour? A contour is basically an area. Okay, so we need to get the outer contour, like the outer boundary of this, in order to draw that bounding box, in order to show you that we have found this color here. Okay, so we will get the contours. We'll get the contour. Spelling is contours. See, most of this function will return unwanted values. Okay, that's why we are using this dash here. We are not taking it, that's all. Okay, so we are only taking the contours from the returned function. So we'll say find contours. We'll pass in our mask, and in the mask we need to find the contours. And what contours we need to find? We need to find the contours that are external. We only need the external contours. Okay, like the outer boundary. We only need the outer boundary. We do not need the inner contours. Okay, and we also need to optimize this contours. We only need a simple representation of this contours. Okay, so that's why this is just used for optimizing the contours. Okay, so to reduce the usage of memory. Okay, so after we have found these contours, we will loop through these contours. Okay, we will loop through these contours in and we will get each contour for the different colors that we have detected. Now we will say we will only take if the contour area is greater than 100. Okay, because there's a possibility that there are several I mean, for example, if we are trying to detect blue color, there's a possibility that in the background there are little bit tiny objects that are in blue in color. Okay, but we don't want to detect it. We only want to detect the large things in blue color, isn't it? So that's why we will say that no, only if the contour is greater than, has a like area that is greater than 100 pixels, only then take it. Okay, take it and get the bounding boxes. I mean the bounding like the boundaries. Okay, we need to get the boundaries. So bounding rect is the function, and we'll pass in our contours. This will return the top. This x and y represents the top left corner, and these two are width and height. So with these four values, we can get top left and bottom right. Okay, so and all the 4 points we can get with these four values. Okay, so we will get these four values from bounding rect function into which we will pass in the contours. Okay, so we will say and now we have received this contours, isn't it? I mean, we received the boundary points, isn't it? So that's all we need to show the bounding box, isn't it? So we will return the color name and the boundaries of for that particular color. So this for loop will loop through all the contours that it has detected, and it will append it with the particular color name. Okay, so yeah, now after this all this we will return the detected. Okay, so that's our main function. Okay, and after we have received this detected colors, so now we have the detected colors, isn't it? So what do we have in detected colors? We have the all the coordinates and the color name, isn't it? So we will loop through both of those. We loop through color name and what, and the bounding box, isn't it? We have the bounding box boundaries, isn't it? In detected colors we'll say x1 y1 x2 y2 is equal to b box. So there's a mistake I think we have made. We are not going to return this like this. Okay, we will return this. So what will be if x is the x and y represents the top left, what will be x plus width? It will be the right corner, isn't it? And what will be y plus h? It will be the bottom corner, isn't it? So x plus w and y plus h will represent the bottom right corner, isn't it? So that's how we need to return this. Okay, so we are returning this like that. So that's why we will get back x1 x2 and y1 y2 here. Okay, from the bounding box. Now what do we do? Now we will take our brightened frame and we will draw a rectangle using this using this what, using the x1 x1 y1 x2 y2 coordinates that we have received. Okay, we will say x1 y1 the two corners. Okay, x2 y2, and we will pass in a color. So let us draw it in green. So we will pass in 255, and the thickness for the line will be 3. Okay, you can adjust this according to you, and we'll also put a text there. Okay, we will put the color name there. We'll say put text. And so where do we need to put the text? We need to put the text in brighten frame, and we need to put the color name dot, let us capitalize it. Okay, let's say capitalize, isn't it? I believe that's a function, color name dot capitalize. Yeah, okay. And so where do we need to put this text? We need to put it as in the location x1, and so basically top, and where, so y2. So where will it, like in the bottom left corner, maybe. I think this is the bottom left corner, isn't it? Yeah, so cv2 dot, so we need a font, right? So font, let's say plain maybe, or maybe simplex. So you can try out different fonts. Okay, I myself don't know how these fonts look like, but you can try it out and find out. Okay, I think I have closed this, isn't it? Yeah, I have closed this, and then we will pass in the font scale. Okay, so it will be 0.5 font scale, and there are a couple of things that we need to mention. We need a color. We'll say 0 comma 255, let's like yellow. Okay, 255, and then thickness 2 and cv2 dot line a. So this will just smoothen out the text. Okay, this is just used to smoothen out this text, nothing else. Okay, so that will do. And then we will also write another text. Okay, we'll write a text like like press the escape key to exit. Okay, so I haven't written the function to exit here, but we will write it soon. Okay, so let us just write the text here. Okay, so I will say press escape key to, this is to exit from the frame that is visible to us. Okay, from the video feed. And we will put this text at, let's say, 1020. So it will be 10 pixels from the left and 20 pixels from the top. Okay, and cv2 the same font we can do. Maybe we can okay, font scale can be similar, and the color can be in black. Okay, let us write this in black. And let us make the thickness okay, thickness is fine. Okay, so that will write that text there. Okay, and now we will show it. Now we have done everything, and we will show it. Okay, we will show. Let us call it let's call it color detection live, live color detection. Okay, and we will pass in our frame. Okay, we'll pass in our frame. So as I have mentioned, we need to close this on key press, right? On escape key press. So let us get the key. So this is how we get a key press while we are running a live video feed on OpenCV. Okay, so this is the code. Just write in whatever I am writing here. So this basically means, CVT to do wait key one means, after reading each frame, wait for 1 millisecond for any key press and read that key press and return it to this key variable. Okay, so that's all this is. Okay, now if that key that we have pressed in that 1 millisecond that it has waited after reading the frame, if it is 27 is the ASCII value for escape key, then break out of this loop. That means stop displaying whatever you are displaying. Okay, so after all these things, we need to release all the screens and everything. Release what's the function? Usually gives suggestions. Okay, is the okay, why is not giving suggestion? Okay, whatever, we'll just type in release. I don't know why it is not giving me suggestions. I think there is some issues. Also, we will destroy all the windows. Okay, there is some issues here. Okay, this code is unreachable. Oh, okay, after we have break, then it is unreachable. Okay, it's fine. Still we will just release it. Okay, if at all it is needed. All right. Okay, now we will call this main function. So if we don't want this main function to run on places where we, in future, if we import this function to any other place and we don't want this main function to run, then this is how you should write it. Okay, if you write it like this won't run when we import it to other files. This will only run when we separately run the script. Okay, so let us try. Let us hope for no errors. Okay, there are lots and lots of errors. So threshold is missing requirement thresh. Okay, let us say threshold. What is it missing? I think I have added an extra that there. So I'm really sorry, I have made a mistake. I should not add this inside this loop. Okay, should be outside this loop. We don't want to loop in this escape text and also the im show function. Okay, we only might need to call it once, and also the break function as well. We only need to call it once. Okay, so now this will definitely work. Okay, this will definitely work now. Okay, one more error. Okay, this is 0. I don't have 2 cameras. Okay, this will work now. Yes, it has worked, and it is detecting the green, blue and yellow colors there, and it is only detecting the blue and yellow color there. And yes, green, blue, only the green and blue colors there. Okay, so yes, it is working, and it is perfectly detecting all the colors as we have mentioned. It is perfectly writing it down below there. Okay, so it is working. So I hope you have enjoyed this video, and you can comment down your suggestions if you have any, and if you need any explanations on any of the topics, you can mention that there as well. and you can just explore with this code. Okay, the code will be there in the comments, I mean the description, GitHub link. You can take it and copy it, and explore with it and make it better. Okay, maybe try and color this, maybe change the blue color to yellow color, I mean the yellow color to blue color or red color or something like that. Okay, we can change that. Okay, so I hope you enjoyed the video, and if you haven't subscribed yet, try to subscribe and like this video and share this video with your friends. Okay, thank you. See you in the next video.